Starting with you, Suzanne, you are maybe hoping to see that the real quantum computer will behave differently than the simulation. That seems to imply that you think the quantum theory that you're using to write the simulation is somehow incomplete. Does that mean does your framework imply that you think there's new physics to be found? And could the reward function that you were talking about be negative action? In other words, everything minimizes the physical action, so could that already be the reward function? In other words, it might already be in physics that we know about already.
So do you mean like kind of Friston's principle, like free energy minimization? So yeah, I don't quite agree with that. Let me answer the first part of your question. Yes, I think it's incomplete. The quantum physics is incomplete. I think what happens is we've studied things like the Schrödinger equation and the Born rule in a limiting case. So it's the case of where the quantum system is very small. So we tend to isolate small quantum systems from the environment and test them. And we also don't put them in feedback loops with the environment, where the output of a choice then affects the input. So my prediction, and again, it needs scientifically testing, because it's a big deal to say, like, quantum theory is wrong. It's never been proven wrong. But my prediction would be when we start putting quantum systems in a feedback loop with the environment in a controlled way, they actually start to deviate from the Schrödinger equation and the Born rule. And I should just also mention, you can't actually simulate quantum systems more than like a few degrees of freedom. So we're really, if you put like many qubits together, we're really in a territory where we can't even simulate like systems more than a few qubits, because you have to move to different approaches like density matrix and things. The Schrödinger equation just can't be computed there. So yeah, I think there's a whole lot of physics that we need to find yet, and I don't think that just this free energy or surprise minimization is enough. I think it's necessary, but not sufficient, because I think, as one of the other presenters mentioned, a way to minimize your surprise is to just not do anything and just go and stare at a white wall all day. So I think there's something else driving it that's kind of on top of that as well. But it's a good starting point.